friends, welcome to Igniter Max with the wonders of the positivity. At this video, we are going to do the chapter of the trigonometry of the compound angles. What are the compound angles? Compound angles are sum or difference of a given angle. Trigonometric function that is listed sine, cos, tan, cosec, sec, cot. We are going to find the compound angles at this video. Previously, we have seen lots of the introduction related to the trigonometry. Yes, the trigonometry tables, identities, ratios, etc. topics we have gone through it. Okay, at the description link also we will be getting it. At this video, we are going to find the complete proof of the compound angles at the trigonometric functions, especially at the trigonometric chapter. It's completely based on the formulas, a collection of the formula we used to remember in the trigonometric chapter. So how we need to remember each and every formulas? It's completely based on the compound angles and all sort of examples in which what all things we can apply and how we need to do it. A complete concept we are going to do at this video. So let's get started. The first trigonometric functions of the compound angles formula is cos of A minus B. What is the formula? It's nothing but cos of A into cos B plus sine of A into sine B. Yes, we are having the proof for this formula, but it's quite lengthy to understand it. So we are going to derive the other formulas with the help of it. So I have written as like as, but over here the A and B are the angles. Yes, so we are going to derive the other formula with the help of the cos of A minus B. Let's get started. Now cos of A plus B is equal to cos of A into cos B minus sine of A into sine B, in which A and B are the angle. So we are going to derive it. Now before moving to the derivation, we will just clear the concept of the trigonometric functions of the negative angles, in which sine of minus theta is equal to minus sine theta, cos of minus theta is equal to cos theta, and tan of minus theta is equal to minus theta. Yes, the concept is clear. If not, then go to the description link. We will be getting the complete concept. So because we are going to use it over here, for that purpose I have mentioned it. So let's get started with the proof. Cos of A plus B, it's nothing but cos of A minus of minus B, in which minus into minus plus. Yes, but I have written the angle B in the negative form. Okay, why? Because I can use this formula, as I earlier mentioned that I'm going to use it for the cos of A plus B. Yes, so it's nothing but cos of A minus of minus B, in which B contains the negative term. It's an angle, and A minus B, take it in that way. So just apply the formula for it. It's nothing but cos of A into cos of minus B. Yes, over here I have mentioned it, plus as like a sine of A, the angle is A, but sine of B in term over here it contains a minus, so minus B. But cos of minus beta, it's nothing but cos of minus theta. Yes, the angle theta is an angle, but over here B is an angle. Yes, so as I mentioned over here theta. Yes, over here theta is the angle, over here B is the angle. So cos of minus B is nothing but cos B, and sine of minus B is nothing but minus of sine B. Yes, and plus into minus is equal to minus, and the formula is cos A into cos B minus sine A into sine B, as we have mentioned it. Okay, even we are going to derive the formula. I have completed with the cosine trigonometric functions of the compound angles, but before proving the sine compound angles, okay, sine of A plus B and sine of A minus B and rest all the trigonometric functions, we'll just prove the trigonometric functions of the complementary angles. Okay, in the allied angles even we can prove it by the compound angles, but before proving it we need the help of the complementary angles. It's nothing but 90 degree. Yes, complementary angle is 90 degree. So we are going to prove it. That is nothing but cos of pi by 2 minus theta and sine of pi by 2 minus theta. We are going to prove it. Cos of pi by 2 minus theta. So we are going to apply the formula of cos of A minus B. This is my A angle. and this is my B angle. So just apply the formula. It's nothing but cos A into cos B plus sin A into sin B. So for me, A is pi by 2 and B is theta. Just apply it. It's nothing but cos pi by 2 into cos theta. Yes, just compare over here, plus sin pi by 2 into sin theta. But we know that cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1. Yes, 0 into cos theta is nothing but 0 and 1 into sin theta is nothing but sin theta. So cos of pi by 2 minus theta is equal to sin theta. It's nothing but proof of the trigonometric functions of the allied angles, complementary angles. We have proved cos of pi by 2 plus theta, that we are also going to prove it over here. It's nothing but cos of A plus B. This is my A and this is my B. Here just apply the formula of cos of A plus B. It's nothing but cos A into cos B minus sin A into sin B. As I mentioned, A is my pi by 2 and B is theta. Just apply the formula over here. Yes, I have applied it. And again, cos pi by 2 is nothing but 0. Minus of sin pi by 2 is nothing but 1. Yes, 0 into cos theta just vanished. And sin pi by 2 is nothing but 1. So minus 1 into sin theta, it's nothing but minus sin theta. Came across the formula of the trigonometric functions of the compound angles. So with the help of the formula of the compound angles, even we can prove for the trigonometric functions of the allied angles. So here is the table in which we have constructed already. Okay, even we can cross check it with the help of the compound angles formula. We will be getting the answer so easily. As we have mentioned that for proving the sine functions of the compound angles, for proving it we need the help of the complementary angles. For that purpose we have mentioned over here. So let's prove the trigonometric functions of the compound angles of the sine. Yes, so sine of A minus B is equal to sin A into cos B minus cos A into sin B. Yes, so we have noted that cos of pi by 2 minus theta is equal to sin theta from over here. Yes, it's nothing but sin theta is equal to cos of pi by 2 minus theta. Yes, and over here for proving it we are going to put the theta value as A minus B. This is my angle. Yes, even my A and B are the angle, but over here for proving it I am going to put the value as theta for A minus B. Here is the solution for it, in which sine of A minus B, yes, sine of A minus B, the angle, it's nothing but cos of pi by 2 minus of A minus B. Yes, in theta value I have just put the value of A minus B. Just correlate with it. Yes, we have put it over here. Now pi by 2 minus A, minus into minus plus, and B as like as. So it's nothing but cos of A plus B formula. Yes, over here we have mentioned over here it's nothing but cos A cos B minus sin A into sin B. Just apply it over here. Okay, this is my A angle and this is my B angle. Just compare in that way and we'll just proceed with the formula. It's nothing but cos A into cos B. A is pi by 2 minus A, cos B as like us, minus sin A sin B. So A is over here, B is over here. Okay, if it find difficulty with the same alphabet, just take it other alphabet like P Q R. Even we can take it in that way also, we can prove it. Okay, so we can prove it in that way, but we know that cos pi by 2 minus A, it's nothing but sin A. Okay, over here we have mentioned by theta. As we have mentioned, theta is an angle, but over here A is also angle. Yes, so cos pi by 2 minus A is equal to sin A and cos B as like us, and sin pi by 2 minus A is equal to cos A and sin B as like us. Okay, now even we are going to prove it for the sine of A plus B also. Sine of A plus B, the formula is sin A into cos B plus cos A into sin B. But we know that sin theta is equal to cos of pi by 2 minus theta, as we have proved it. Yes, but over here for proving it we have put the value theta is equal to A plus B. Okay, just similar of sine of A minus B we are going to prove it. Yes, so sine of A plus B is equal to cos of pi by 2 minus A plus B, in which A plus B over here I have mentioned as a theta. Yes, it's nothing but sine theta, cos as like us, pi by 2 as like us, and theta over here a plus b. Okay, just have put the value at theta as the a plus b. It's nothing but pi by 2 minus a plus into minus b. Yes, so it's nothing but cos of a minus b, the formula. Just apply it over here. It's nothing but cos a into cos b plus sin a into sin b. Yes, as I mentioned it over, this is my a angle and this is my b angle. Just correlate with the formula and we are getting it. But we know that cos of pi by 2 minus a, so remember cos of pi by 2 minus theta is equal to sin theta sin a, and sin pi by 2 minus a is nothing but my cos theta cos a. For tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Yes, but we know that tan theta is equal to sin theta divided by cos theta. Yes, but over here theta is equal to a plus b. Yes, so same process we are going to apply it over here. That is nothing but sin theta, that's something over here a plus b, and cos theta is nothing but a plus b. So it's nothing but sin a plus b formula, as over here we have mentioned it. Just put the value as like it's, and cos a plus b. Okay, cos a plus b formula is over here. Just put it as like us. And now a small twist. Divide each and every term by cos a into cos b. For proving it, we are going to divide it. Okay, each and every term I have divided by cos a into cos b. And over here it's nothing but cos b and cos b is cancelled over here. Yes, over here cos a cancel, and over here cos a and cos b also cancel. Now at last I'll just write over here, it's nothing but sin a divided by cos a is nothing but tan a. Yes, and plus as like us sin b divided by cos b, it's nothing but my tan b. Yes, and over here each and every term is cancelled. It's nothing but 1 minus sin divided by cos a, it's nothing but tan a, and sin b divided by cos b is nothing but my tan b. And here is the formula. The next formula derivation is nothing but tan of a minus b. Yes, it's nothing but tan theta is equal to sin theta divided by cos theta, but over here theta it's nothing but by a minus b. So I have mentioned theta as a minus b. Yes, it's nothing but sin a minus b formula, and over here cos a minus b formula. Just put it as like us. Yes, we have done with it. Now okay, I have mentioned over here. Now the same process, divide each term by cos a into cos b. Divide each term. After dividing it, we will be getting the answer as cos b cancel. Yes, cos a cancel, and over here cos a and cos b is also cancel, and rest all the term we'll just put the formula. It's nothing but tan theta is equal to sin theta by cos theta. It's nothing but over here, so tan a minus tan b plus okay 1 plus sin a into cos tan a, sin b into cos b is nothing but tan b. Yes, by the formula we can apply this. So tan of a minus b is equal to tan of a minus tan b divided by 1 plus tan a into tan b. Yes, so the formula that we are going to derive, it's completely correlated with the one of the formula. From the one formula we have derived the other formula. With that two formula we have derived the other two formula. Yes, it's completely a correlated formula. Now even we can derive for the cot of a plus b and cot of a minus b also. I'll just list it out the formula. Okay, just write off it very easy. Okay, just write off. The same process as we have done for the tan, we are going to apply it. Okay, but for the exam point of view, if we can remember for the cot a plus b and cot a minus b, it's well and good. But if not, then also no problem, even we can do the sum. With the help of the trigonometric functions of the compound angles, we can prove the lots of many formulas, like trigonometric function of the allied angle. The full table we can prove it by the trigonometric function of the compound angles. Now the other formula, it's nothing but sin 2 theta, cos 2 theta, sin 3 theta. Each and every formula we can derive by the compound angle. With the help of it we can derive. That's what we are going to show it over here. It's nothing but sin 2a. A is nothing but an angle, so it's nothing nothing but sine to theta. In books we can see the sine to theta, over here sine to a, it's nothing but actually same. Over here I have mentioned that angle A is an angle, over here theta is an angle, it's nothing but same. Yes, so sine to a, it's nothing but sine a plus a plus a is nothing but 2a, and sine as like as, yes, it's nothing but sine a plus b, the formula, the trigonometric function of the compound angle formula. I have just listed the formula above the proof. Yes, so just apply it as like a sine a into cos a plus cos a into sine a. Okay, the a and b may be the difference, as I mentioned a and b are the angle. Over here the angle is a, so it's absolutely same. So it's nothing but sine a into cos a plus cos a into sine a. It's nothing but 2 sine a cos a. 2 times is repeated, is nothing but 1 plus 1 is equal to 2. That's what sine a into cos a plus cos a into sine is nothing but 2 sine a into cos a. Now the other formula, cos to a, cos to theta formula also we are going to derive it. It's nothing but cos of a plus a plus a is nothing but 2a. Yes, it's nothing but cos of a plus b, the formula we can apply it over here. It's nothing but cos a into cos b minus sine a into sine b. So cos a into cos a is nothing but cos square a minus as like a sine a into sine a is equal to sine square a. So cos square a minus sine square a. Yes, we have derived it. Okay, now the other formula, sine 3a, it's nothing but sine 3 theta. That formula also we can derive with the help of the compound angles. It's nothing but sine 2a plus a, it's nothing but sine 2 theta plus a, it's nothing but 3a. Yes, and we can apply the formula sine a plus b formula, we can apply it as I have mentioned it. Okay, just apply it as like as, and we know that sine to a is equal to 2 sine a cos a, and cos a as like as, and cos to a is equal to 1 minus 2 sine square a. Okay, I have just shown the construction on the right hand side of the part. Yes, I have derived cos square a minus sine square a, but 1 minus 2 sine square a, how did it came? Okay, with the help of the trigonometric identities, I have just shown it on the right hand side. So please go through it also, you will be getting it. And sine a as like as, now just do the multiplication with each and every term. Okay, over here I have multiplied, it became as cos square a over sine a minus 2 sine cube a. Yes, and cos square a, it's nothing but 1 minus sine square a. By the trigonometric identities, the sine square a plus cos square a is equal to 1. So cos square a is equal to 1 minus sine square a, and 2 sine cube as like as, rest of the term will be as like as. Now just multiply this term with this term, and after doing the multiplication we came as 2 plus 1 is nothing but 3 sine a as like as. 2 minus 2 minus 3 is nothing but minus 4, and sine cube a as like as. So this is the formula for sine 3a. I've just shown it with the help of the trigonometric function of the compound angles. We can prove lots of the formulas. Start with the first examples. So the first example given is, we need to find the value of the cosec 15 degree. What is the value of it? Okay, according to the trigonometric tables, we know the value of the 30 degree, 45 degree, 270 degree, 360 degree. We have the value of it, but we have not got the value of the sine 15 degree, cosec 15 degree, like 15 degree we have not mentioned it. Yes, but we can find it with the help of the compound angles. We are going to find it. Let's get started with it. Now, according to the trigonometric ratios, the formula, okay, cosec theta is equal to 1 by sine theta. Yes, so cosec 15 degree is equal to 1 by sine 15 degree. Over here theta is 15 degree. So can be written that way. Now the next part is, we need to add and subtract the two angles. Okay, any of the two angles, so that we will be getting the 15 degree. That any of the two angle, that is some restriction we need to select from the trigonometric tables. That is nothing but 30 degree, 45 degree, 60 degree, 90 degree. Any angle we can take it from the list of the formula given. Okay, we can take it any angle, but by adding or subtracting we need to get the value as 15 degree. Okay, just think about it. So one of the way is 45 degree minus 30 degree. Can we get the 15 degree? Yes. So can we write it over here? Sine 15 degree is equal to sine 45 degree minus 30 degree. Okay, now we need to find the value of sine Okay, sine 15 degree we need to find it, and we need to find the ratio of 1 by sine 15. So we will be getting the answer as cosec 15 degree. So let's get started with the solution. Now 45 degree minus 13 degree is equal to 15 degree, as we have seen. Now it's nothing but sine A minus B. Yes, in which A and B are the angle. Over here 45 degree and 30 degree are the angle. Can we apply the formula over here? Yes, absolutely we can apply the formula of sine A minus B. It's nothing but sine A into cos B minus cos A into sine B. Just apply it in sine 45 degree minus 30 degree. Only part is A is 45 and B is 30 degree. Just apply it over here and we will be getting the answer. Okay, sine 45 into cos 30 minus cos 45 sine 30. We know the value of each and every trigonometric function listed in the screen. Yes, so just put the value as like as sine 45 is equal to 1 by root 2, cos 30 is equal to root 3 by 2, and sine keep it as like as. Okay, and cos 45 1 by root 2 and sine 30 1 by 2. Okay, now just do the calculation. Over here 1 into root 3 is nothing but root 3, and root 2 into 2 is nothing but 2 root 2. Yes, and over here 1 as like us and 2 root. Over here 2 root 2 is common in both the terms, so just take it in the common, and root 3 minus 1. We have found the sine 15 degree, but the question is asked as cosec 15 degree. So what we need to do it, 1 by sine 15 degree is equal to cosec 15 degree. Sine 15 degree is equal to 1 by cosec 15 degree. Yes, just put it as like us and we will be getting the answer. So for example, they have asked only for sine 15 degree, only this step is enough. Okay, no need for this step. But over here they have asked us cosec 15 degree. So what we have done it, 1 by sine 15 degree. So just I have applied the one more step. Okay, this is how we need to do it. Any angle, whether it is the 25 angle, 75 degree, any degree. Okay, we can do it by the trigonometric functions of the compound angles, and with the help of the trigonometry tables we can find very easily. At the second question, we need to show that tan 3x tan 2x tan x is equal to tan 3x tan minus tan 2x minus tan x. Okay, for proving the trigonometric functions from LHS to RHS or RH to LHS, here is the small tip. LHS and simplify to get the RHS value, or start with RHS and simplify to get the LHS value. Otherwise, the most important is reduce if required both LHS and RHS to the same expression. Especially for this example, I am going to use the third point. We prove it from LHS to RHS and from RHS to LHS. Even we can write over here. I am going to show the relation with the proof. Okay, it's nothing but 3x is equal to 2x plus x. Just hide the functions. Okay, 3x is equal to 2x plus x. Now put the tan over here, and over here tan a plus b formula we can use it. Yes, we have used it, and over here it's in the denominator form. Take it in the numerator over here. Yes, we have took it, and just do the multiplication of it, and now the actual formula comes it off. We need to show that the actual term comes it off. Tan 3x over here and tan 2x plus tan x. Take it over here, it comes in the minus, and over here minus tan x, tan 2x, tan 3x. Take it over here, positive. Okay, this is what we need to show it, that we have shown without taking the LHS and RHS value. We have just took the relation of it. The third main question, we need to show that cos pi by 4 plus x plus cos pi by 4 minus x is equal to root 2 cos x. Okay, we need to show it. It's nothing but from LHS to RHS, RHS to LHS we have proved it. But at the second question, we have not took any LHS and RHS. We have took the relation of it, and we have proved very easily. Okay, in that way also it's alright. Okay, now over here. Okay, I took the LHS value, and I thought that cos a plus b and cos a minus b formula we can use it, and we can find it very easily. Okay, so we know the value of cos pi by 4, sin pi by 4, each and every value we know. Just I have put the value as like as, and it comes of 2 root 2 cos x. Yes, so it's nothing but over here 2, it's nothing but root 2 into root 2. Yes, and root 2 cancel, and and one more root, so cos x, root 2 cos x. This is what the question asks. The fourth question, if tan a minus tan b is equal to x and cot b minus cot a is equal to y, and we need to show that cot a minus cot b is equal to 1 by x plus 1 by y. So we can use this all the given content and we can prove it. Okay, for that purpose they have mentioned over here. So I am going to take the value of cot b minus cot a is equal to y. Okay, after taking it, cot is equal to nothing but 1 by tan. Okay, cot theta is equal to 1 by tan theta. Over here theta is b, so let's take the angle as b, and over here angle is a, so let's take the angle a. So 1 by tan b minus 1 by tan a, and y as like as. Now, okay, I have just done the denominator same. Okay, I have just done the rationalizing the denominator. Multiply by tan a at the numerator and denominator. Over here multiply by tan b at numerator and denominator. And tan a, tan b came the common from both the terms. So I took this as a common, and over here tan a minus tan b. So but I know the value of tan a minus tan b over here. Just put the value of, just take the cross multiplication of it. Tan a tan b goes over here and over here. So it's nothing but x by y. Okay, and we need to find the value of cot a minus cot b is equal to 1 by x plus 1 by y. We need to prove it. So take the LHS value. This is my LHS value. It's nothing but 1 by tan a minus b. So this is my angle. A minus b is an angle. So cot theta is equal to 1 by tan theta, and we can use the formula of tan a minus b. Okay, I have just used it, and over here we have the value of tan a into tan b. It's nothing but x by y. I have just put the value and just do the rationalize the denominator, multiply by y at the numerator and at the denominator. So it's nothing but x plus y divided by xy. So if we will took the value in such a way, I'll just show it. X by xy plus y by xy. Yes, so x common and y common. It's nothing but 1 by y plus 1 by x. That's what I have mentioned over here. Now here is the proof. We need to prove that sine 105 degree plus cos 105 degree is equal to cos of 45 degree. Okay, as at the first I mentioned that we don't know the value of the 15 degree, 105 degree, 75 degree. Yes, but the other trigonometric tables we know the value of 30 degree, 45 degree, 60 degree, 90 degree, 270 it. But over here, sine 105 degree and cos 105 degree, how we need to find it? We need to add or subtract any of the 2 degrees so that we will be getting the 105 degree. For that purpose, I have done the 60 degree plus 45 degree is equal to 105 degree. So sine 105 degree is nothing but sine of 60 plus 45 degree, and over here also cos 60 degree plus 45 degree, and we can use the formula of sine a plus b and cos a plus b. Just I have done it, and we know the value of sine 60 degree, 45 degree, okay, cos for 60 degree. Yes, have just applied it and I got the answer as 1 by root 2. 1 by root 2 is nothing but my cos 45 degree. So this is nothing but the RHS value. The next question, they have given us sine 45 degree plus theta minus sine 45 degree minus theta is equal to root 2 sine theta. So let's take the LHS value and we will prove it by the RHS. Okay, over here they have given in the form of a plus b. Okay, sine a plus b and sine a minus b. Just put the formula over here and we will be getting the answer very easily. Just input the value of sine 45 degree and cos 45 degree and we will be getting the answer as root 2 sine theta. So this is nothing but the RHS value. For watching this video. If this ignited math is so helpful, then do like, share and subscribe, and don't forget to comment.